Hey everybody, and welcome back to the channel. In this video we're going to be looking at this old thing here that I saw in a local listing, a barn find. Now technically not really local if you have to drive an hour to pick it up, but anyways I thought it would be pretty interesting to take a look at this. I like these old machines where you have no clue what's actually inside. I was kind of fascinated by the form factor, this being an old desktop case with a 5¼ inch floppy drive. So yeah, let's take a look. We have the key lock, we have the cool little display here, we have reset, turbo button, power. We have your standard 3½ inch disk drive. We have a 5¼ inch floppy drive. We have a CD-ROM drive. So yeah, kind of a mixed bag. We have the power supply on the back, serial ports. We have a keyboard connector, old style. We have a parallel port. We have the VGA port and a sound card. Now, one thing I always look out for is the VGA port and the orientation of the connector. And the orientation here indicates that this has to be an ISA or a Visa Local Bus video card, because the orientation of the VGA port on a PCI card will be upside down. So yeah, that's already a good thing. Other than that, I was anxious to see if it would boot, so I just turned it on. And I immediately heard some activity. The computer seemed to be booting. There were no explosions, but something else caught my ear. Now that doesn't sound right, does it? So yeah, before we continue, let's open up the case and see what we have inside, because this is always the most fun part. You actually bought something, you have no idea what it is, and now you're seeing it for the first time. And I immediately noticed that we have PCI slots, we also have standard ISA slots, and we also have Visa Local Bus slots. So this is definitely a more modern 486 based system. The CPU fan is still running, so that is good. So we can safely power on the system. But first I want to see what kind of cards we have inside. And here we have a video card, as I expected, an ISA 16-bit Cirrus Logic video card. Very old video card, as this one only has 256 kilobytes of RAM and was produced or installed at around 1992. We have a more modern sound card here, the Sound Blaster Vibra 16XV from 1997. So definitely an afterthought for this computer, probably some kind of upgrade. I can tell from the sound of the hard drive that this is a Seagate, and initially it seems to work fine, but then, you know, this sound really isn't good. But yeah, I was anxious to see what kind of CPU we had in here, so we'll look at the hard drive later. So let's take off the cooler, which is held in place by these plastic clips here. And what we see here is the beautiful AMD DX4 100 MHz CPU. A really nice CPU from AMD. Kind of mid-90s vibes. So yeah, this computer was definitely upgraded at some point, because I cannot imagine having a 5¼ inch floppy drive and such an old video card paired up with this DX4. But let's start up the computer. We have 8 megabytes of RAM. We have the American Megatrends AMI BIOS here from 1994. This one has kind of a graphical user interface. It's not text-based. You can even use your mouse in the BIOS. The hard drive is detected as a 500 megabyte hard drive, which would be period correct for the mid-90s. And you have your standard set of options here for, you know, internal cache, external cache, boot options. We also have the L2 cache mode here set to write back. More on that later. We have some Cyrix options and some other advanced stuff that you can configure on this computer. So yeah, fairly modern BIOS for a modern 486 with onboard PCI, onboard I/O, automatic detection of hard drives. So yeah, let's start up the computer, see what it does. It detects the hard drive. So it is able to boot into MS-DOS. It has a French version of MS-DOS installed. It loads up the creative plug-and-play sound card driver, finds the CD-ROM, has antivirus software installed, and yeah, basically it seems to boot up fine. Although, you know, that hard drive sound is definitely something to worry about. And that's something that we notice right away as we launch into Windows for Workgroups, Windows 3.11. And we notice that it is unable to complete the boot into Windows as the hard drive starts to make a weird sound again. Now I tried multiple times to get Windows to start, and sometimes you actually get into the Windows screen, but you get this drive error that it's unable to read from the disk. And just by looking at the content of the hard drive here, we see a lot of these CHK extensions here, meaning that, you know, ScanDisk has definitely run on this computer. It has found probably lots of damaged sectors, and so yeah, this is not looking good. So yeah, I'm pretty sure you can still salvage some stuff from this hard drive. For example, I can load up applications which are on here, but you know, you never know what kind of files got damaged along the way, and if these, you know, pieces of software will not end up crashing at some point because, you know, some file is missing or has been converted to a check file. So yeah, I'll see if there's something interesting to salvage here, but for now I'm just going to be looking at ScanDisk and see how bad the damage is on this hard drive. And so yeah, long story short, I mean, there were lots of errors on this hard drive. I mean, ScanDisk was able to fix some, but you could definitely hear from the hard drive that it wasn't sounding all that healthy. And when it started the surface scan, you could already see that there were some bad sectors, and I can only imagine that this number will increase as we do a full surface scan. And this was indeed the case. I've sped up the footage a lot, and you know, you can see that it finds additional bad sectors along the way. And so yeah, this basically means that the hard drive is dead. This is not something that I would trust to store data on. So yeah, unfortunately the hard drive is toast. But yeah, let's continue with the disassembly of this PC. So we have lots of jumper wires here. Luckily, everything is pretty well documented on the motherboard itself. We're going to disconnect all of the cables here. So this motherboard has onboard IDE connectors, has a standard IAT style power connector. So let's get everything out of the way here so that we can get the motherboard out of the case. And so here it is, held into place with one screw. We have our 486 motherboard here. But before we take a closer look, let's continue with the disassembly. We have lots of drives here that we still need to remove from the case. We have the 3.5-inch disk drive. Now this one also holds into place this little PCB here, which is responsible for the LED display on the front of the case and the turbo switch. So yeah, it's always a good idea to take some pictures here because, you know, reassembling these jumper wires here isn't always the easiest thing. We can continue with a 5.25-inch floppy drive and a CD-ROM drive. And what we have here is the hard drive, which is held into place with two screws on one side of the hard drive. So yeah, this is definitely not the original hard drive which was in this computer. This is a 545 megabyte Seagate hard drive. So yeah, also gonna remove the power supply because, you know, it's very dusty in this case here. Obviously we also need to remove the power button here as it is part of the power supply. And yeah, just look at all that buildup of dust here. So yeah, we're gonna remove everything, make sure that we clean it up. But before we do that, let's take a look at the motherboard. And here we have it. Nice little 486 motherboard with an AMD DX4 100. Now it's not immediately obvious what kind of motherboard this is, as there are no visual markings on it that indicate some kind of brand. There is a model number here on the top left corner, a version 3.4B/F, and doing a quick Google search, I was sent to the excellent website called the Retro Web, which has a whole database of all kinds of motherboards. It has a search functionality, so even if you don't have any markings on the motherboard, the chances are really high that you will find it on this excellent website. And so I found out that this was in fact a PC Chips M919 version 3.4B/F. We have 3 PCI connectors here, so yeah, pretty modern stuff. We can add a PCI video card. We have 4 16-bit ISA slots, one of which can be used as a VESA local bus. So yeah, 3 ISA slots 16-bit, 1 VESA local bus, and 3 PCI slots, so yeah, lots of room for expansion. We also have this Coast module here, which is used to add some level 2 cache. Now this motherboard does have 2 cache chips here at the top. Right back WB14L128, so it seems to indicate that this is 256 kilobytes of level 2 cache. But when we look at the traces here, we see something odd because they seem to be connected to one another, but other than that, I don't see any traces from these cache chips going to other parts of the motherboard. Even on the back here, you can see that you have this area here where everything seems to be connected, but it's just not going anywhere. And that was a very common practice for this particular manufacturer of motherboards, PC chips. So what they basically did here was add these kind of fake chips on the motherboard that you couldn't even replace with actual cache chips because you didn't have the traces to support them. Now there are other variants of this motherboard model where the cache chips aren't populated, but even with those you cannot insert real cache chips because the traces are not there. So you're forced to use this Coast module. Now, it wasn't all that uncommon in the 90s to come across these 486 motherboards that didn't have level 2 cache. But then the consumer kind of got the impression that they were sold a motherboard which had missing component, because obviously, you see lots of IC sockets there which aren't populated. That might give you the impression that you are being sold something which is incomplete. But at least you could upgrade these motherboards because all of the vias and the traces were there to support level 2 cache. And it's understandable from an economic point of view as well that some motherboard manufacturers decided to sell these motherboards without level 2 cache, because this level 2 cache at the time was very expensive and probably made up the most expensive part of the entire motherboard. But what PC Chips did by adding these fake cache chips on the motherboard is a whole nother level. So yeah, this just gives the consumer the impression that it has level 2 cache on board, while in fact it does not. And the only way to upgrade or to add some level 2 cache on this motherboard is via this Coast module. And to make matters worse, this Coast module here is not compatible with other Coast modules. So you need a dedicated PC Chips Coast module to add level 2 cache onto this motherboard, which is really annoying because obviously these are going to be very difficult to find nowadays, and you're basically left with a motherboard with 0 level 2 cache. And they even had a modified BIOS that said write back cache on during startup, which was kind of hard coded in the BIOS. So despite the fact that there isn't any level 2 cache here, you again get the impression that there is some kind of level 2 caching going on here. Okay, so moving along, we have a UMC chipset, the UM8886BF. Pretty common for 486 motherboards. We have a coin cell battery, obviously this being a more modern 486. We have the AMI BIOS, American Megatrends, which contains that specific code to display the write back cache enabled, while in fact there is no level 2 cache. We also have onboard connectors for IDE, floppy, parallel, and serial ports. So yeah, that's really convenient, not needing to have an extra expansion card for that. We have a standard AT style power connector, standard DIN style keyboard connector. We have 2 sticks of 4 megabyte EDO RAM, so for a total of 8 megabytes of RAM. The board supports a variety of different CPUs from different vendors, all configured using jumpers. You can set the bus speed using just jumper, for example. You can specify the voltages using another set of jumpers here. It supports both 3.3 volts, 4 volts, and 5 volts. So yeah, jumper wires here for the case connectors, all pretty well documented here on the motherboard. The voltage regulators here for the different types of CPUs. And yeah, the CPU that we have in this system is this AMD 486 DX4 100 MHz, a 3-volt CPU. This one was manufactured at the end of 1994, so week 52. So yeah, really nice CPU here with the Windows logo. Fits nicely into this motherboard. Socket 3, obviously. So yeah, there's this cutoff here on the bottom left. So you definitely want to take note of that, because it is possible to insert the CPU the wrong way, and that would have catastrophic consequences, obviously, for both the CPU and potentially also the motherboard. So yeah, look at for this notch here on the CPU, align it with the socket, and then insert the CPU like so. Regarding the cache issue, you can use various tools to verify both the level 1 cache on the CPU and the level 2 cache on the motherboard. Now, normally we should see a dip here around the 256 kilobyte mark, which we don't. Same thing using this cache check tool. We see the performance impact around the 8 kilobyte mark, which is the level 1 cache, but no level 2 cache found here. So yeah, I've added this other DX4 100 MHz computer with L2 cache. And as you can see here, when we do the same test, we see the performance impact of the level 1 cache. But around the 256 mark, we should see another drop here, which is the impact of the level 2 cache, which we see happen here, this kind of slope here. And also using the cache check tool, we see that there is level 2 cache present. So I think it will be very interesting to see how my crippled DX4 compares to an actual DX4 machine with proper level 2 cache, and just see what the overall performance difference is on various levels. I'm also going to be taking a look at this Cirrus Logic video card which was installed. I'm guessing this is a remnant of a 386 that used to be in this desktop case. So the computer got upgraded, but they forgot to upgrade the video card. We can see what the effect is of adding various other ISA video cards, or make use of the fact that this motherboard also has a PCI connectors. We can also take the Visa local bus route to see what kind of performance impact that will bring us. And overall, still some stuff to do. I mean, we need to clean the PC. I already cleaned up the case a little bit, so that's already looking a whole lot better. But we're not done yet, obviously. The front panel here is still a little bit dirty. We need to clean the keyboard, the case, so we need to get everything back in proper shape. And then yeah, continue doing some benchmarking. So yeah, I hope you stick around for part 2 of this video. This should come out next week. So I hope you've enjoyed part 1 of this video, this little walkthrough of this old PC that all of a sudden turned up in a local listing. And I'm actually glad that I ended up getting this main board with these fake cast chips. I was aware of their existence, but I never seen them in real life. So yeah, it's pretty nice to have a board like this as well. So I really hope you've enjoyed this video. I hope to see you in the next one. If you like this kind of content, please consider giving it a like, subscribe to the channel if you haven't already done so, and take care, everybody. Bye-bye.